Hi all, let's see the next topic of Unit 5, Instruction Pipeline. In today's lecture, we are going to discuss about an introduction to instruction pipeline, the flowchart of an instruction pipeline, and a four-segment instruction pipeline. So coming to the introduction, we have already seen the concept of pipelining. What do you mean by a pipelining? So pipelining is basically it is a technique of decomposing a sequential process into multiple sub-processes, and each sub-process is executed in a specially dedicated segment, and it works concurrently with all the other processes. A pipeline processing, it occurs not only in the case of a data streams, but it can also be implemented in the case of instruction stream as well. So most of the digital computers which are used nowadays, which have complex instructions, they require the concept of instruction pipeline to carry out their operations like fetch, decode, execute and all. So in this type of an instruction pipeline, a sequence of instructions, they can be executed by overlapping the different stages of a pipeline, by overlapping the fetch, decode and execute phases of an instruction cycle. So this type of a technique is used. Why we are going to overlap the stages of your pipeline in an instruction stream is to increase the throughput of your computer system. When you try to execute more number of instructions in a less amount of time, the throughput or the performance of your system obviously increases. So an instruction pipeline, it reads the instruction from the memory while the previous instruction is being executed in other segment of the pipeline. So when one instruction is being executed in one segment, the next instruction will be fetched from the memory. That is how an overlapping works. Thus we can execute multiple instructions simultaneously, and this type of pipelining technique will be more efficient if the instruction cycle is divided into segments of equal duration or equal time interval. So if you consider in general, the computer needs to process each instruction and there are certain steps for each and every processing of the instruction. So it involves fetching an instruction from the memory, decoding the instruction, calculating the effective address, fetch the operands from the memory, execute the instruction and store the result. So these are the steps which are involved in completing the execution of an instruction. So first we need to fetch that particular instruction from the memory based on the address. And next you need to decode that particular instruction. Next you have to calculate what is an effective address of the particular instruction. And then you have to fetch the operands, the operands which are required to execute the particular instruction. And then the execution of an instruction. And once we complete the execution, you need to store the result at the permanent storage locations. So these are the different steps in general. So if you consider the flowchart of an instruction pipeline, you're going to divide these steps into four segments. Segment 1, segment 2, segment 3 and segment 4. The first segment deals with fetching an instruction. The second segment deals with decoding the instruction and calculating the effective address. The third segment deals with fetching the operands from the memory. And fourth step deals with the execution of an instruction. So let us see this flowchart. First, whenever an instruction the execution of the instruction starts from fetching the particular instruction from the memory based on the address of the particular instruction. And in the next step, once an instruction is fetched, you need to decode that particular instruction to find out what type of an instruction it is, and you, if at all you need to calculate an effective address, that has to be done in the segment 2. So once you decode the instruction, you come to know what an instruction it is and what is an effective address. In the third clock cycle, you fetch the particular required operands from the memory. And in segment 4, you execute that particular instruction and store the result. Here, when the first instruction is in the execution stage of the pipeline, the second instruction will be in the fetch stage of the pipeline and fetch operands from the memory. Whereas the third instruction will be in the decode stage and the fourth instruction will be in the fetch from the memory. So there will be an overlapping between multiple segments of the pipeline so that more number of instructions can be present in the pipeline at the same point of time, as so that the throughput of the particular computer system increases. This is how normal execution of an instruction pipeline works. But consider an instruction is a branch instruction. Say an instruction I1 is in the execution stage, whereas an instruction I2 is in the fetch operand stage. And consider there is an instruction I3 which is a branch instruction. And in case of a branch instruction, when a branch instruction is, oh, once we fetch the particular instruction, we don't know that it is a branch instruction. And consider the one instruction I4 is in the fetch stage. So whenever the instruction a branch instruction is being decoded, and when we come to know that it is a branch instruction, then you need to update the value of PC. So branch instruction will have a certain target instruction. If you consider I1, I2, I3, if I2 is a branch instruction, the next instruction that has to be executed after the I2 may not be I3. It may be some other instruction IK, which is not according to the program order. So you need to update the value of the PC to the particular instruction IK, so that after the instruction I1 and I2 are completed its execution, the pipe or the pipeline will be updated with the instruction IK, so that this particular instruction will be executed next. So whenever you encounter a branch instruction, then you have to update the value of PC and empty the pipe, and you will complete the execution of the previous instructions I1 and I2, which are at execution stage and fetch operand stage. Okay. Similarly, whenever there is an interrupt, so whenever interrupt occurs during the execution of an instruction, you require to handle the particular interrupt. So if it is an interrupt, you provide an interrupt handling mechanism, so that we update the value of the PC and empty the pipe. So this is how an instruction pipeline works. So while an instruction is being executed in a segment 4, the next instruction will be in the fetching an operand in segment 3, and the effective address will be calculated for the third instruction. And similarly, for the fourth instruction, it will be fetched from the memory. So this is normal process how they overlap. Four different instructions overlap in progress at the same point of time. Once in a while, when an instruction in a sequence may be a program control instruction, such as a branch. In that case, it causes a branch out of a normal sequence. In that case, you cannot execute the instructions after the branch instructions according to the normal program order. So what happens is, in that case, the pending operations in the last two segments. So whatever instructions that are being executed in these two segments, they will complete their execution, are completed, and all the information is stored in the instruction buffer is deleted. So that what happens now, you have to update the value of the PC. The pipeline then restarts the new address stored into the program counter. So similarly, whenever there is an interrupt request during the execution of an instruction, so it will cause a pipeline to empty and start again from a new address. Here, this particular figure shows the operation of an instruction pipeline with the help of a four segment pipeline. So it is divided into four segments: fetch, decode, fetch the source operands, and execute. We have divided the execution of an entire instruction into four stages, where the first stage is said to be called as F5, which is fetches an instruction from the memory. And segment 2, we call it as a DA. It decodes the instruction which is fetched from the memory, it will be decoded in this particular segment. And the effective address is also calculated here. And the third segment deals with fetching an operand from the memory. And finally, the fourth segment, you're going to execute that particular uh, instruction in the last segment of the pipeline. So when you consider this, these are the 7 instructions which are present in the pipeline. In the first instruction, if you consider, it will be fetched in the first clock cycle, decoded in the second clock cycle, fetch operands in the third clock cycle, and executed in the fourth clock cycle. So when the first instruction is in the execution stage of the pipeline, the second instruction will be in the fetch operand stage. And similarly, the third instruction will be in the decoding stage. And the fourth instruction will be in the fetch instruction stage. So if you look at the clock cycle 4, at the same point of time, there are 4 instructions that are overlapping with each other and which are present in the pipeline at different stages of the pipeline. So this is called as an instruction pipeline. So here, if you observe the third instruction, consider the instruction 3I3 is a branch instruction. So in this case, it will fetch the fetch instruction will be done in a third clock cycle. Decoding step will be done in a fourth clock cycle. When you decode the particular instruction, we come to know that this is a branch instruction. So whenever it is a branch instruction, the target instruction of the particular branch, what is the instruction that has to be executed after the branch instruction, it takes certain amount of time until the execution time of the particular instruction is completed. We don't know what is a target instruction of the corresponding branch instruction. So at that time, either the fetching of has to be delayed until the execution of the branch instruction is completed. After the execution of the branch instruction is completed, then if consider the branch is not taken, then you can continue with fetching the next instruction according to the program order. So here the instruction is fetched on the first clock cycle in segment 1, is decoded in the next clock cycle, the operands are fetched, and finally the instruction will be executed. The fetch and decode stages overlap due to the pipelining. In case of a third instruction, it is a branch instruction. So here, when the branch instruction is being decoded, the fourth instruction is being fetched. But as it is a branch instruction, it may point to some other instruction which is when it is decoded. Only when it is decoded, we come to know what is the target instruction of the branch. So thus the fourth instruction is kept on hold until the branch instruction is executed. So when it gets executed, then the fourth instruction is copied back and other phases continue as well. If the Thank you.